November the 30th, 2023. Guys, you're looking at our website, bpearthwatch.com, and a couple of things that we're going to talk about. One is the article that Tina put up this morning from space.com that has everything to do with the incoming CME tonight and some of the geomagnetic storms and their effects in probably red auroras instead of green ones. We'll take a look at it, but My Patriot Supply emailed us and told us they're continuing the sale on the Alexa Pure water filtration system for $169.95 ship. Can't beat it, guys. The other thing on the other side of the page, thank every one of y'all for ordering the new CD and the 3-pack. You get the 3 CDs, all for the same shipping price and marked down to $9.99 each. Thank y'all for that, because I mentioned it before. That's what we're using for our vet bills and our food for the Huskies. So you get a good deal, and it helps us out too. Now, let's go down to the article. It is right here. It says, strong auroras likely as a powerful solar flare eruption hurls possible cannibal CME towards the Earth. And that's the video that I did, I think, 2 videos back. But this is an update on that. But let's click here first. And it's going to bring you here. It says auroras could reach mid-latitudes on November 30th and December 1st. Again, 0600 is the estimated arrival time of the CME, but that's done in universal time. That would put it up very close to midnight here in the U.S., especially on the East Coast Central Time. Daylight savings time changes some of that, but they do tell you in these models there's a plus or minus 7 hours of a window. It could come 7 hours early or 7 hours late. They're usually within an hour or so on these models. But what's important, guys, is this happened the last time we had a strong CME come in. It wasn't this strong, but in Texas, you saw red auroras. Now, what's cool about the site, and just save it, is that if you're in a place where it's going to be raining and that we've got that weather system moving on us tonight, and it's going to encompass Texas and Louisiana and move into Alabama, Tennessee, through there. It's moving north and northeast. The skies are going to be cloudy. But on this particular site, let me scroll down. This is where they're talking about the powerful M98, which if you went up 2 more points, it would be an X-flare. I think one of the satellites actually registered that much energy. But they've got information here. And then where to look. The northern lights are typically viewed from high latitudes, often confined to Alaska, northern Canada, and northern Europe. But during the times of heightened solar activity, with particularly powerful solar eruptions, it becomes possible to see the aurora borealis much further south and the southern lights, or the aurora australis, further north. In other words, the CMEs impacting both poles. If you're hoping to catch a glimpse of the aurora, you should try and head to a dark location away from big city lights. Make sure to keep an eye on the northern skies or southern skies if you're in the southern hemisphere, making periodic checks at regular intervals. Auroras are rather fickle and can lie dormant before suddenly flaring up at a moment's notice. It says if you're unable to make it outside to hunt for auroras in person, we have a compiled list of some of the best aurora webcams so you can enjoy the thrill of the northern lights from the comfort of your home. Check it out, guys. Most of these, I think, are YouTube channels. Now, this is the Abasco, Sweden live webcam. Notice your timestamp here. This is one of them. If you scroll down, you'll see the one in Finland. By the way, I said most of them are YouTube, but going back up here to Finland, this is a Twitch video. See right there? So just to correct that. Going back down now, we were at the Spikenes Peninsula in Norway, and there and in Denmark, guys, they get some excellent aurora images. Here's Fairbanks, Alaska. So you can come here and either save the links or just save this page where you can come and look around, or maybe subscribe to their channels and things like that. Then you come down to BANF or BANFF Canada, YouTube video here. Beautiful images. And I think that's the top 5 that they have listed. But that should give you a pretty good view from either side of the planet. And, of course, with it being midnight Eastern time, then we will not see the brunt of the storm, but remember, tectonic plates can take pressure from one side and shift that pressure around the entire globe. Now, this is from November 5th, guys, about 3 weeks ago, from Vassdale, Norway. It's Jan Maj Nagelson. And look at that picture. This is when we were going through a geomagnetic storm, not as strong as the one we're going to now, but that sudden burst turned from the green you normally see into red because of higher energy particles penetrating further into our planet. And another shot, same night, same photographer. Amazing to see the reflection in the stream or river here. It's we were told to watch for signs in heaven, and these are changing signs. Guys, I don't know if you remember when Mike from Around the World first called in. It was 10 years ago this month, and we were watching Comet ISON as it came around the sun. But a fellow called in, and Paula said, who are you? And he said, I'm Mike. He was taking in live calls during that time. And I think Paul said, Mike who? And he said, Mike from Around the World. And that stuck. But anyway, I don't know if it was that particular show because he still calls in. It's been 10 years. But many years ago, he was talking about that these auroras and the energy in the skies, you would start seeing more and more red skies. And it's because of the increased energy waves, not only from the sun, but from space, that are hitting our shields and penetrating them. The stronger they are, the redder they are, and we're going to look at some of the details of why that is. Now, the model has not changed. Notice the impact, or the very wall of impact, which is almost straight up right there, is at 0600. Now, someone said, you said midnight, but that's 6 a.m. in the morning. But, guys, most of the scientists use universal time. And you notice right here at the bottom, UT. I think New York now is 5 hours behind this because of daylight saving time, But anyway, 0600, around midnight tonight, but I did say that you have a plus or minus 7 hours of window. They are fairly accurate, but this is where the cannibal CME has overtaken the first two. And all of that energy combines and creates crazy magnetic fields because they're different polarities, they're different speeds. So you're just colliding them together right before they hit our planet. And if you remember in that video, I pointed out in the plasma density chart at the top, the green line is red, the other two are the Stereos A and B satellites. But normally this chart starts at around 5 and then go 10 to 15. This is plasma density, centimeters cubed. That is how powerful a wave, how intense a pressure is going to be, and the amount of particles. When this is going to reach near 60, think of that, 60 centimeters cubed in density. The thicker it is, the more powerful, the stronger they are. And I'm trying to answer a couple of questions from the last video about this, and someone asked, would CERN take advantage of this? And guys, in the past, we've seen it almost every time with it, that CERN cranks up, that it bends the magnetopoles closer to the Earth. That's important, especially during the event we see coming up now. But CERN is not operating. They shut down November 20th. They will not reopen it until March, and you can see it right here. No beam before March 2024. And it was updated yesterday, but the beam actually shut down on the 20th. We'll look at the shutdown page. And it gives you beam 1 and beam 2 information. You can see they're faulty, not ready. They're turned off. And this was the last image coming out of beam 1 and beam 2. And they're running through 17 miles of extremely powerful magnets that have to be kept at temperature, I think, below 2 degrees Celsius, about the temperature of outer space, if I'm not mistaken. But anyway, and what they're trying to do is with the magnets is get these to collide into a single beam, and then they get their explosions, right? But this is the unwinding as they turned it off. Notice your timestamp right here, November the 20th. So it's down. It won't be playing a factor in this event. Now, guys, for years, we've been able to use this particular model to watch the impacts of the sun and of CERN on this magnetopoles right here. This is our shields that we're looking at. This one does not move. They have taken most of all the instruments down, guys, that like this one that we use forever to watch these events coming. They don't want us to see what it is that may appear, or they don't. I guess they think we're just dumb cattle and we don't need this information. What does it matter to us? We're just tax slaves. Anyway, this is a still image from today, though. And what we're going to be looking at is the standoff, or the RE right here. Now, the normal standoff, or RE, and I'm going to explain that in another section here in just a moment, is about 12. This is 10, 11, 12, 13, 14, 15. I'll show you what that means. This one's compressed just a little bit further. In the center, in the white dot, you've got half of it white, half of it black. The white half is because that's the sun-facing side. The other is the night side of the planet. Energy's coming from right to left. And we've seen it for years. You get a strong solar flare. I've seen the magnetopoles collapse all the way into the orbit right here of the GOES satellites. And beyond that, especially when CERN was coming in, I've seen the top and bottom. You guys have to completely collapse well past that and let everything pour in, because CERN's magnetic field that is created and generated is 100,000 times more powerful than the delicate balance that God gave this planet. Think about that. Anyway, this RE we'll look at what that means, but this is going to start fluctuating, and it's really a shame we don't have this model available to us in a moving model, but at least this is up. This is what was going on at 1827 hours. Again, universal time. Come back, you'll be around 1300 hours, or about 1 o'clock this afternoon on the East Coast. Now, Australia has not taken their moving model down, and it's backwards. I guess maybe that's because of the Southern Hemisphere, but on the other model, the light-colored side of the planet was to the right. This is the same thing, just backwards. And the darker blue is the night side. This is our magnetopoles right here. I'm going to play it forward, but before I do that, I want to point out a couple things. Here's 1746 UT, solar winds at 346 kilometers per second. That's just a little above normal. Protein density at 1.1 protons, centimeters cubed. What are we looking at? Possibly 60. So 60 times the amount of energy that's here now as we're speaking compared to what's coming in tonight. Now, the Earth is here. These are satellites in the satellite band right here. It lists the satellites from IPSTAR through the Sky Musters, the GOE systems, and the Feng-Yang satellites. And they're orbiting. We'll play it forward. Now, the RE, that's why I want to show you this one. It's important. That is the distance between the center of the Earth and the outer edge. That's 1 RE, okay, from the center to the edge, the radius. Then right here where it says 5, that's 5 times that. So this is the distance from here to the center is 5 times the distance from here to the outer edge of the planet. This is 10 RE and 15. Normal RE is around 12 on just a calm day. But what we'll see is pressure build in as I play it forward, and it's always going to expand back out like pushing a balloon, so it will jump out further after a compression event. Let's play this just a moment. Now, this is going to give us through this day universal time. It will stop at our current time now. You can see there's solar pressure here, throwing this thing back towards the average of 12 and expanding back out. It's almost like the quiet before the storm. And there's you saw that right there. You're getting close to 11, and that's the last time stamp for today at 1746. Let's play it one more time and take a look at this. Here we go. Same images, just going back through it again. Notice when it bends in, the proton density increases. You're going to see a couple of 2s right in there coming from this 1.0. That's when you're seeing the bends. Now, I went back and stopped this about an hour ago when we saw one of those major pushes, and that actually, look at that, 5.8 protons per centimeter cube. That's, again, the density in that size, and we're expecting possibly 60. And looking back at the model, guys, very close to that point right there. See, 60 would be a line right through, very close to where this peak is, right there. So it's going to be a very hard impact, and you can tell that by the straight line. It's going to hit stereo B just a little bit later in the blue, right there. You see the bend back, and you can see the straight up. This is paused right at the impact on our planet. But that straight up wall is like hitting a brick wall at full speed. If you have a gradual rise, like maybe back here or the beginning of this impact, it's not as strong, especially on the tectonic plates. But this could be very impactful. And if you go back to our website, there's about 30 or so links on the left, and about midway or so, you're going to see spaceweather.com and solarham.com. They both have good information. Notice right here, it does give you information about the solar wind speed. If you click on Discover, it's pretty much live as this crosses the Discover satellite. So let's just take a look at that. This will be the indicator or the watching factor for this incoming event. When you get there, it's going to give you 3 bits of information about the solar wind speed. The density here, and notice about 1 hour ago, that spike where we saw the magnetopause pull back in and the density rose to about 5.3. Notice right there, 5.82. Notice the numbers as I go across. That's what this is indicating. But look at the solar wind speed. It jumped from 400, which is kind of the average, then it getting back down to normal around 320 here. And at that same time, that spike brought the solar wind speed up to 486 kilometers per second. Check that out. And maybe a little higher. There's a 493. And we're probably going to see this in the 700 and 800s and well over 1 million miles an hour before the event's over with. This third line is the temperature of the solar wind speed. The more particles, electrons in it, the faster it moves, the higher the temperatures. And you can see that is also indicated right here. And when we have these events, when that radiation pours in, they are warmer. Some penetrates in a scattering motion as they hit the atmosphere, a wide scattering all the way to the surface of our planet. And while you're on space weather, take a look at some of the articles in the middle. The bottom one is where we were looking at the images of the red auroras. These were coming from Norway. But here, this is coming from Shenandoah National Park in Virginia at the same time, November 5th. It says what could happen during a G3. It says, here's what we can expect. The last G3 class storm on November 5th sparked not only broad auroras, but also a deep red SAR arcs across the world. Greg Redfern photographed this example from the Shenandoah National Park in Virginia. He said, I didn't realize I had photographed a SAR arc until I processed my images. The next day, stitching the two of them together to reveal its shape. Check that out. SAR arcs look like auroras, but they are not. They are a glow of heat energy. Guys, and we saw that temperature increase just an hour ago on the model before this at the solar wind temperatures, along with the speed and density. But the SARs they're not auroras. They are a glow of heat energy leaking into the upper atmosphere from Earth's ring current system. Donate-shaped circuit carrying millions of amps around our planet. During the November 5th geomagnetic storm, these red arcs were observed as far south as Texas and California. So some places you may get some pretty good images, but maybe why he didn't see it until he processed it was notice the light pollution from whatever city this is near, again, Shenandoah National Park. So he had that. If he had not had that, he may have seen it live. Not sure, just saying. Now, let's take a look at the sun. I'm going to start playing it. It's up to the current time, but I've got it back to the 29th. And this area right here is the energetic area that we're getting the solar flares from. But behind it, we've got another problem. Another thing that's happening is I've noticed the solar filaments kicking up. And there's one of these have erupted, but it's going to be behind the cannibal CME and off to the right of the planet. I don't think we're going to see much effect from that. But when you get an opening in the solar canopy, this is what you see. And this is one of the largest ones that I've seen, especially this year. What happens, you can see all of these loops. See this right here, guys? It's looping around. And that's how the energy is returned to the sun most of the time. But if that canopy is not present in an area, the solar wind pours out of this hole in the direction of the hole. So as we're about to turn, as the sun's turning to the right, you'll notice everything move. But when it gets to a right in here in the center, just below the equator of the sun, it's directly Earth facing. Then that's when the solar wind is going to start stacking back up on top of us after these solar flares come through. Let me play it. Again, 2 days of images, ending with the last one today. As this opening gets closer to the center, the solar wind pushing out of it is going to start affecting our planet. It takes a couple of days to get here. But again, what's happening again, where you have the canopy, the energy is captured in these solar loops. There's a filament right there. But these filaments, guys, can be very dangerous. They're like a major whip. And if they're in this area of the sun, it always seems to affect Alaska, the Aleutian Islands. I've seen it many times. But the filaments can be dangerous in themselves. Here now, as we get into today, you can see solar active areas here, these sunspots, are starting to turn away from directly Earth-facing. And so if we have continued events, it will be more or less to the right of the Earth or a glancing blow, unless we have a major X-flare, which it's still a possibility. Then you're going to have that 8.2 minute time for that what would be called photons, not protons, because it's light energy, to strike our planet, moving 93 million miles on average between the sun and the planet. In 8.2 minutes, you'll feel the photon, not the proton energy we're waiting on now, but the light energy. And so if this will die out, that'll be good if it just maintains what it's doing now. But it still has a chance of X-flares. But this will be the next event right here, this coronal hole or coronal opening. We're watching it, guys. We'll update it. Again, you can go to spaceweather.com. You've got that meter on the top left that's going to show you the increases in the solar wind speed as this event gets closer to us. Again, it's a heads up, guys. Be safe.